As we start this video, I want you to make sure that you have your periodic table handy, as we will be writing on our periodic table throughout this video. Alright, we're going to start off with what we call monoatomic ions. Monoatomic, the prefix mono means one, so we are just looking at one ion. We're not looking at them combined together yet. These can be any type of ion, so positive or negative. We're going to take a look at the cations first. So cations we know are always positive, and these are going to be your metals. So these are the ones that are going to be losing their valence electrons. That's why they're positive. We're going to be adding these to our periodic table here in just a few minutes, but the 1A column will always form a +1 charge. It's a family trait, which means that they lose one valence electron. The 2A family is a +2 charge, which means they lose 2 valence electrons. And then we have our 3A family. And if you look at the 3A family, you have boron, aluminum, gallium. You have several metalloids and some metals. But aluminum is really the most common metal that is going to form a charge, so you won't see the other ones very often. So aluminum is really the only one that we'll concentrate on, and so that would be a +3 charge. So that means it loses 3 valence electrons. And we've already mentioned once before how you name a cation. It's the same as the name of it off of the periodic table, and then we either put ion or cation behind it. So for instance, if we wanted to name the aluminum with a +3 charge, we would either say this is the aluminum ion, or we could say this is the aluminum cation. Now on your periodic table, what I want you to do is you need to put that this 1A column forms a +1 charge. Anything within that column is going to be a +1. We're going to need that in the next video or two when we start to actually bond elements together. This is our 2A column, and so those all form a +2 charge. And then we mentioned aluminum being the only one that we'll really concentrate on. You won't see the other ones used very often, if at all, in ionic bonding, and so that would be a +3 charge. Write those into your periodic table. Now let's take a look at our negatives. These are your anions, and these are going to be your nonmetals, or in some cases maybe a metalloid. So these are nonmetals, and they're going to gain valence electrons. That's why they are negative. And our 5A column, that's going to form a -3 charge, which means that it's going to want to gain 3 valence electrons. Again, they're gaining or losing in order to become stable. That's the whole point. They want that octet. The 6A family would form a -2 charge, so that means that they're going to gain 2 valence electrons. Your 7A column family is a -1, which means it gains a valence electron. Now, as far as naming your anions, this is not going to be the same as the element's name. So the cation, same as what it is on the periodic table, but for your anion, it is not. First of all, you're going to start with the element's name, but we're going to take the ending off and add the ending IDE, ide. So for instance, phosphorus. If we want to name the phosphorus -3 ion, we wouldn't say the phosphorus ion. We take the OUS off and we would call it the phosphide ion. Let's look at the sulfur, -2. We wouldn't call it sulfur ion. You call it sulfide ion. You get rid of the UR at the end and add the IDE ending. That's only for the negative ion. That's the only one you change with the IDE ending. Now, let's get our periodic table out. We said that our family 5A is going to form -3 charges. So that would be nitrogen, phosphorus, so on. Oxygen family, that would be your 6A. They're -2s. And for your halogens, 7A, they form -1 charges. So make sure you put those on your periodic table. We definitely are going to need those in the next few videos. Now let's look at our transition metals. We kind of skipped over the B elements. The ones there in the middle are transition metals. So they are 1B through 8B. And the reason that we've skipped over those is because we always have exceptions. That's what makes this kind of difficult sometimes, is you have to know some of those exceptions. They don't always form the same charge over and over again, like the ones that we've already put on our periodic table. So they can form more than one cation. They are metals, so they always will be positive, but sometimes it might be a +2, maybe with a different element it's a +3. Not something I will expect you to memorize. There's a way for us to give you that information when we're writing the names. So for example, iron. Iron is a transition metal. It's number 26. And this one, we can't just put a +2 up at the top of the family and say everything in this column is a +2, because it doesn't work that way. So sometimes it's a +2, other times it can form a +3 charge. So when we're looking at 4A, there's an exception in this family. Tin and lead are metals in the 4A column. They are the only metals. The other ones are nonmetals or metalloids. And so these also can form more than one charge. And when we are naming a transition metal, we are going to put the charge that the metal has as a Roman numeral in the parentheses. So for example, if we wanted to name Fe+2, it is still a cation, so you take the name directly off the periodic table, but now because the charge is unique and it isn't something that we can just know from looking at Fe on the periodic table, we need to take that +2 that we have on our element symbol, and we're going to turn that into a Roman numeral. So we put that as a Roman numeral 2 in parentheses, and then we have ion. So you can't just call it the iron ion. We have to put that Roman numeral in there. Now, because lead is a special case where it is a unique situation, it's not a transition metal, but it does have those varying charges. We would still keep the name from the periodic table, lead, but then that 4 would be written as a Roman numeral in the parentheses there. Now, there are also a few exceptions that are transition metals, but they don't have the varying charges like your other ones do. And that will be silver, which is always a +1, cadmium is always a +2, and zinc is always a +2. So let's take a look at our periodic table. You need to write these exceptions in here until you get to practicing with them, and then you have them memorized. You need to know these. So tin and lead are exceptions. You need to highlight them, color them, outline them somehow. These are going to be exceptions that need Roman numerals. That need Roman numerals. Now, everything that is in this transition metals section will need Roman numerals, just because those are the ones that we don't have a specific plus or minus, a plus charge for. Except we had 3 exceptions right toward the end of that last slide. We said silver. Silver is an exception. It does not need a Roman numeral because it always forms a +1 charge. Cadmium right beside it never needs a Roman numeral. It's always a +2. And zinc also does not need a Roman numeral. It is also a +2. So those form that little triangle there. Those are exceptions that absolutely need to be in your periodic table. We'll be using those a lot. Really quick, let's finish up with polyatomic ions. You will be given, if you haven't already, a little half sheet of paper that has a list of the polyatomic ions on it that you're required to know for this class. Poly means many, so this is an ion that has more than one atom to it. So monoatomic, 1 atom. Polyatomic has more than one. So for instance, SO4 with a -2 charge has sulfur, and it has oxygen in it, so polyatomic. And again, the little subscripts tell us how many of each. So we have 1 sulfur, 4 oxygens. And this group of sulfur and oxygen are going to lose, are going to gain 2 electrons, the -2 charge. So they're going to gain 2 electrons. These are tightly bound groups of atoms. They behave like a unit, so we can't separate the sulfur and the oxygen. They are kind of considered one thing, and they do carry a charge to them. Most of them on your list end in "ite" or "ate," and that "ite" or "ate" ending just tells you that oxygen is present if it ends in "ite" or "ate." Now, "ite" means that there's one less oxygen. So, for instance, if you look on your -2 column in that chart, you're going to notice SO3, which is a -2. That is sulfite. And then SO4 with a -2 is sulfate. So if you can remember the ones that end in "ate, and by memorizing these, you are going to have to memorize them, you want to start with all the ones that end in "ate," because if you can memorize that, SO4 minus 2 sulfate. Then if I say, well, what is sulfite? You can say, well, "ite" means that there's one less oxygen, so that means that it's SO3. Still with the -2. So we're going to start by memorizing all of the ones ending with "ate, and then we will add more of them to our list as we get those the first group down. And that kind of ends about ions and how they're named. Our next 2 videos will get into how we write out formulas and how we name ionic compounds.